right, good day, everybody. Welcome to week number 4 of this balloon lab assignment. I'm doing a recording because I need to be away from lab for the morning 2 sessions, somewhere else on campus doing a STEM outreach event. So I'm recording everything for consistency between the different classes. You're going to be in the more than capable hands of the fellows teaching assistants. So they're going to be walking around to ask about the deliverables and help the lab progress as if I was there. They have my number in case anything comes up as well. So the deliverable today, the things that the teaching team will be looking for is basically the expansion of the free body diagram, which we talked about last week. So looking at that neutral buoyancy equation, really in terms of the knowns and unknowns. So what are the quantities that you know? What do these variables represent? And then what is the variable that you're trying to solve for? So we'll really accept for either balloon, the hot air balloon or the helium-filled balloon. In all reality, I would expect to see both of those from you at this point in the game. One thing that I do want to clarify with the helium balloon specifically is we're asking you to draw a comparison between the amount of helium calculated just using the ideal gas law. So imagine we have some volume of space and it's filled with helium at a certain pressure and temperature. How much mass has to be in that volume just based on the ideal gas law? And then we're going to ask you to compare that value to what the force balance equation says has to be true about the mass of helium in there. So I know there's typically some confusion because you need to utilize the ideal gas law in the force balance, but we're asking you to compare the result of helium, the mass of the helium from the force balance expression to what would only be necessary using the ideal gas law in the volume of space of helium. So hopefully that makes sense. All right, now looking ahead to next week, really, and kind of the primary activities that I'm expecting you to complete this week is we want to look at how do these different parameters change versus altitude. So we want to use the same mass of helium. So this helium balloon, we're going to imagine that we're taking this balloon and we're moving it up in the atmosphere to a different location. So we're not actually going to look at how would it really move. It would just be, say, for example, we have this balloon in our car, no helium's leaking out, and we drive up to Vail Pass or somewhere like that. What would the volume need to do in order to reestablish neutral buoyancy? So revisit this equation, visit the governing equation so you can look at that. Likewise, for the hot air balloon, what would the temperature of the hot air balloon, the one that we have in the lab that you can see set up by the station here, what would the temperature of the hot air inside that balloon need to be at different altitudes? So how are you going to look at that? Well, we're going to use what's called the standard atmosphere model, and this you'll cover more in your 2702 class. So I'm not going to go into a lot of details of where the standard atmosphere came from, other than to say that MATLAB has a built-in function that's going to allow you to just call the function in a certain altitude, and the output of that function will be the parameters that we need. So a representative pressure and temperature of the fluid at the different altitudes. So how do those things change? We're going to use this model to get a more representative value. Now, it's important to understand that the standard atmosphere model is just a model. The conditions today are very likely different than what they would be in the standard atmosphere model. That's okay. We're just going through the exercise of pulling information from some other source and applying it to what we want to look at. And that's how these different parameters that we're interested in. So the hot air and the volume of the helium balloon would change if we had this balloon at different altitudes. Now, I would like to point out there's a couple different standard atmosphere functions. Make sure you use the right one. I say Atmos COESA, it's specified in the lab assignment. Please make sure that you look there. There's another function that trips people up, and that's the Atmos CISA function, something like this. Basically, that one is valid for a while, and then it holds all the parameters constant above a certain altitude. That's not what we want. We want to see how those parameters actually change. So make sure you use the correct function. And again, that's specified in the lab assignment. Next week, we're looking at the hot air balloon expected temperature. So that's something that you should be working towards. what is the temperature that would be necessary? So again, independent from the experiment, independent from what you saw last week, and then for those of you that need to see it again this week, what temperature is necessary for the hot air balloon to reach neutral buoyancy given the conditions in the lab? So that's what we're going to look for. This is deliverable next week. And the week after that, how do these parameters versus altitude change? And really, that's the last piece of the assignment. So hopefully, today you can start working on the next 2 deliverables almost in tandem, start writing some MATLAB code, and then start finalizing the lab assignment. I did mention before with the helium balloon, so jumping back to the experimental data with the helium balloon, we posted 3 different cases and some questions came up. Well, do we average all the cases? Do we average the masses and the heliums and these other things? And the response that I would like you to think about, if that's a question in your mind, is what are we trying to get at? We're trying to see the mass of helium for a single balloon. Now, if you wanted to do some kind of average, we would look at the average of the meaningful information, which would be all of the masses and all the balloons at the end. So carry the calculation through, treat those balloons independently. So balloon number 1, figure out how much mass is in that balloon number 1, independent from balloon number 2 and 3. So I know we talked about this before, but that typically causes some hiccups here and there. All right, everybody, that's all I have for week number 4. Thank you, and I will see you when I see you.